Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah! Check out my new weapon. Piranha gun! Oh, yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. I'm doing a demonstration. Oh, ah! Goodness. It's so difficult sometimes to get the piranha back inside of me.
Hello, geometry students. Welcome back to a new chapter, chapter 4. We're looking at transformations in this chapter. We're going to have different transformations that we're going to go through, as you can see there, from 4.1 to 4.3 and then 4.5, and then a couple of things in there with 4.4 and 4.6. But let's jump into 4.1 now. This is translations is the title for this one. This is a particular transformation that we will see. We're going to be performing these translations, perform compositions as well. Before we get there, let's go ahead and look at our little cartoon today. So this is from a cockpit of a plane. The pilot says, "Sorry to interrupt you folks, but we just had a report of some turbulence ahead, so please stay in your seats a little while." And he turns to his co-pilot, "Ready? 1, 2, 3. And like, turn the plane, ah, great old time. Back on the intercom, "Well, folks, guess we're through the worst of it, and, oh, wait, looks like they're coming into some more turbulence." All right, so a fun cartoon to take a look at first. But we just watched also that little Despicable Me. Remember that from the Despicable Me movie when it was about Vector. And the reason why I put that there and that I wanted to talk about vectors, because that's what we're talking about today. We're actually talking about vectors. So here in your vocabulary, you see your first vocabulary here is going to be a vector. So on page 94, you want to copy down this for vector. And it is what he said. It's a mathematical term, he said, it's a quantity that has both direction and magnitude. So a vector is a quantity that has both direction and magnitude, or size, magnitude meaning size. And it's represented here, and I drew one, it's represented in the coordinate plane by an arrow from one point to another. So you have point A and point B, and you draw an arrow from one point to the other point. And so this would be vector AB, we would call that. Also on your vocabulary is a few more things here on this page. Transformation. So for transformation, you want to write this down, that it's a function that moves or changes a figure in some way to produce a new figure. So you want to write that down for transformation. A function that moves or changes a figure in some way, and we'll figure out what those ways are here as we go through them, to produce a new figure. So you're producing a new figure, so you have maybe a shape like a triangle or a square or rectangle, and you're going to perform this transformation, which is going to move it or change that some way to produce a new figure. And that new figure is called an image. So right here, and I wrote that down here, this is what you want to say for image, that it's the new figure. The new figure that you do get is called the image. And it says another name for the original figure is a pre-image. So I wrote that down here as well, that a pre-image, which you want to write there for that, is the original. It's the original figure. So the new figure is called the image, and the original is the pre-image. All right, so make sure you get those down on page 94 for your vocabulary. And let's take a look again at vector one more time.
Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah! with both direction and magnitude. Oh yeah! Oh yeah!
So a vector commits crime with both direction and magnitude. That's what a vector is. So we see here a few more things on the vocabulary, but you can just highlight them here in this core concept on page 95. You got an initial point and a terminal point here for the vector. So we're specifically looking at this vector core concept. Your initial point here is your starting point. So you can maybe highlight that, initial point or starting point. And you can see that's P. So your vector here is in green. And so the starting point is here at P, and the arrow is pointing at the terminal point or the ending point there at Q. And so the vector is named vector PQ. And you can see here that it's not a segment up here, it's not even an array. So there's a definite symbol here for the vector, and it's kind of like a line with a little bit of a tick mark here at the end. So this is not an arrow, line, and then it goes up a little bit. So it really is a shape of a V only, but it's like a little bit of a check mark almost. And it's read as vector PQ then. You have the horizontal component, so that would be this part right here. How much has it changed from P to Q horizontally? That's 5 units on this diagram. And then you have a vertical component which goes up, and so that's basically like your rise of a run from a slope. Your run part would be the horizontal component, which is 5. It's going to run 5 over here. Your horizontal would be like the rise. It goes up 3 units. So you're always going to look at that from the initial point to the terminal point. And then it says component form. So there's another form we can write a vector in. So a component form of a vector, and you want to highlight this part here, is of a vector combines the horizontal and vertical components, so that the component form for this vector PQ of this one here is 5, 3. And so this looks very similar to an ordered pair, like we have X and Y. And so basically you have like your change in X here, a change in the horizontal, change in X, and this would be the change in the Y. That would be your vertical component there. But you notice that these are not parentheses, these are like sideways V's, showing this is for vectors. And so that's the component form for a vector. Okay, so here we are with our extra practice. This is at the bottom of page 95. It says name the vector and write its component form. And so as we kind of look at this, we're going to name the vector first. So for number 1, we want to look for what the initial point is and the terminal point. So our initial point is M, because that's where it starts from. You can see the arrow is pointing at the terminal point N. So this is going to be vector MN. It's got to be that way. You can't say NM. And so we're going to use that little symbol for the vector above it. And so it's going to have this MN with a little symbol here, kind of like almost a check mark above that. That's the vector symbol. And then we want to also, write its component form. So we want to figure out what's the horizontal component and the vertical component. So starting with the horizontal component, from M, it goes over this many, 1, 2, 3, 4. So it's going to the right, which means it's going to be a positive number. So you also got to see the direction that you're going to be going in these forms. If you go, in the negative direction, then your component's going to be a negative number. So it's going in the positive direction, 4 units. And so that's going to be 4 for the horizontal component. And then for the vertical component, that's going up from here up to N. So it's going to also be positive. We're going to go 1, 2, 3, 4, 5, 6. So 6 for the vertical component. So we want to put that into our component form, 4, then 6. So your horizontal first, this is like the X first, then the Y, just like an ordered pair, but not with parentheses. It's going to look like this with like sideways V's, 4, 6. All right, so I want you to try number 2 and number 3. Do the same thing. Write out the name of the vector and eventually get your component form for each of these, and then go ahead and play it again to check your work. All right, so hopefully you've paused the video and now you're just checking to see what you got on 2 and 3, if it's correct. For number 2, you should have this for the name of the vector. It should be vector BA, because it starts at B, goes toward A. So initial is B, terminal is A, starting point, ending point. And then our component form, we're going to be from B, the horizontal. So you want to do that first. So your horizontal is going in the negative direction. So you got to do this first here. You're not going to go down and then, right? Usually I do this way. I mean, you could do it that way, I suppose, but this way I think is more understandable. Do your horizontal first, which is going to be 1, 2, 3, 4, 5. So that's going to be a negative 5 this way, and then you're also going to be going down 1. So it's going to be a negative 5, negative 1. So in the negative direction here is what we have, negative 5 and negative 1. And then for 3, K is the first initial point, and it goes towards J, so K, then J, vector KJ, like that. And from your K, horizontal component, that's going to be going to the left. Okay, so you are going to the left, 1, 2, 3, 4, 5. But then for the vertical, you are going up 3. That's a positive direction. So negative 5, positive 3, that should be our component form, and make sure you have the sideways V's, not parentheses. So that would get confusing, and it's not an ordered pair. This is a component form. It tells you how to get from K to J, basically. You're going to move 5 to the negative direction, then go 3 up. It's really giving you the map, or the kind of the directions toward from K to J. All right, let's take a look at our joke of the day. What do you call a duck that steals? What do you call a duck that steals? A rubber duck. Instead of a rubber duck, it's a rubber duck. All right, so on page 95, we see another core concept there, just right above those last vector ones we just did. This was on translations. So a translation, it says here, moves every point of a figure the same distance in the same direction. More specifically, a translation maps or moves the points P and Q of a plane figure along a vector, vector AB, to the points P prime and Q prime. These little, little marks here are what you would call it as a prime, kind of like Optimus Prime, but we're going to call P prime and Q prime. So that one of the following statements is true. And here it shows you the statements. And so you have basically your original figure here with the blue. This is the segment, PQ segment. And we're going to move this segment this direction. And see, here's the vector. The vector's there's your arrow. And so you can see a vector going this way, a vector going that way. It's exactly the same thing. It moves it here to your P prime and Q prime points. And here's what you can write in your vocabulary on the last page, 94. You can just say that a translation, it shifts the figure left or right, up or down. So that's what it does there. A translation is going to either shift it left or right, and it could also shift it up or down. It's not going to shift it left and right, or it's not going to shift it up and down, but it could shift it like left and up, or right and up, or right and down, or something like that. Okay, also on page 94, we have a couple more vocabularies to put down. And first one is rigid motion. Rigid motion, and you can just write this down for rigid motion. It's a transformation that preserves length and angle measure. So it means it doesn't change the length of a segment or the angle of a figure. So if it's a triangle, all the angle measures of the triangle will stay the same if it's a rigid motion. Another name for rigid motion is isometry. So you can call it that as well. But a rigid motion maps lines to lines, rays to rays, segments to segments. And on this postulate, it says a translation is a rigid motion. So this type of transformation that we're talking about in this lesson, translations, which is going to shift it just right or left, up or down, it is a rigid motion. It preserves the length and the angle measure. In fact, we're going to see that every single transformation we're going to do is going to be a rigid motion except for one. When we get to 4.5, we're going to look at dilations, and that's the one that's not a rigid motion. But the other three that we're going to see on 4.1, 4.2, and 4.3 are all going to be rigid motions. And then right here it says composition of transformations. You can put this down for your vocabulary as well. That basically when you have two or more transformations are combined to form a single transformation, that's a composition of transformations. So you might have, okay, it's going to move, over here, and then it's going to move up here. It's going to be more than one transformation. So you can have it moving right, like on this figure right here, you have translation 1 moves it this way to your red part, then translation 2 moves it up to your green part. So from the blue to the green, that was a composition. It went from here first, then it went up here. And then you can also see down here 4.1, a composition theorem. The composition of two or more rigid motions is a rigid motion. So if you have a translation and then another translation, so that means that your composition there is going to be a rigid motion still. So two or more rigid motions still results in a rigid motion. That means it didn't change the length of it, still the same length as the original, still the same angles if there is angles there. Okay, back on our extra practice, page 96, asks us here to, in these 4 through 7, the vertices of a triangle ABC are given to us, right there as ordered pairs. It says translate triangle ABC using the given vector, graph triangle ABC and its image. So we're going to use these vectors here, and these are going to be like the directions for us to get the new triangle that we want to use. So the first thing to do is just plot these points. So we want to plot A, B, and C here. So go ahead and do that on your one, but realize that you can see here every box is worth 2. So you got to keep that in mind. So when you start doing A, 1 is just half a box, and then you're going to go up 2 right to there. So that's where A is going to be at. A is right here at this point. And then which is actually a little over there, but that's okay. B, 5, 1, so you're going to come over 5, there's 4, 5 would be about halfway here, and then 1, going to be going up just 1 point. And, let's see. Okay, so 5, 1, we can put right there, and you're going to call that one B, 5, 4. Same X, but just go up to 4, so that's going to be up there, right up here at 4, so right along that same line. And so there's C. So we just want to now connect these dots together to create our triangle. So we'll just connect those and make our triangle like that. Okay, so now it gives us our original. This is going to be now what we're going to move using these vectors. So for 4, and I highlighted these in the color I'm going to do my triangles in, so you can keep them on, know which one I'm doing. But you also can I'm going to number it as well, so on your paper you can just number which triangle goes with which. So this one says -4, 0. So we're going to basically move all 3 of these points just 4 to the left. It tells us the direction here it's going to go is in the negative direction. The X, it's just got a horizontal. 0 here means it's not going to go up or down. So there's no changing it up or down. So it's just going to go 4 this way. So A would now be 1, 2, 3, 4 just over here. C would be 1, 2, 3, 4 here. B is going to be over here. So we just move all of them 4. You can see now it's over here. It's in blue. That's number 4. So we moved it 4 units this way. On 5, I'm going to do this one in green. We're going to go down. We're going to the horizontal is -2, which means we're going to go left 2 units. But then we're going to go down 4 units. So if we go left 2 units from here, so this is 1, 2, and then we're going to go down 4. It puts us down to here for A. You go left 2, down 4, puts us there for C, left 2, down 4, and so on. So you can kind of see where it's going to be. Just right down here, there's number 5. So that's what we've moved it left 2 and down 4, and now your vertices should be all right here. And then for 6, 0 doesn't mean it's not going to move left or right at all. It's not moving left or right, it's just going to move down with -5. So each one of these is going to go down 5 units for our vertices, and that's just going to put us down here in red. So 5 units from B. So 1, 2, 3, 4, 5. We're down here at this point. C goes down 5, puts us there. A goes just down 5, puts us here. And so that's going to be number 6. And then for 7 here in yellow, we're going to go right 1 unit. So we're going to go this way 1. So we're going to go back 1 unit here. Puts us right there at 6 for C and B. Right back here on 2 for A. Then we're going to go down 3 units. And so for the yellow one, it's going to be right down in here. So 1 to the right and 3 down for A, or for this yellow one. That's number 7. And so there you can see them. So there's all of the ones on your paper. So you just want to draw these on your paper, just number them, put the numbers like I got in here, so you know which one is which. Okay, problem 8 and 9 now. It says write a rule for the translation of quadrilateral PQRS to quadrilateral P prime, Q prime, R prime, S prime. Those little marks up here, these mean the word prime. And so here's our original, the one that's in the, kind of the dotted here is the new one. So this would be the pre-image, we would call this, and this is the image. So when you see the P prime, that's going to be the image now. This would be called the pre-image. So keep those words, those are the vocabulary words that we need to keep in mind, keep straight. So image, pre-image, original is pre-image, new one is the image. And so we want to just see, okay, what's the rule going to be for each of these x's and each of these y's, because we have ordered pairs for all of these. It's a rigid motion, so we're just going to be moving the x and the y. So if you just think about what you're doing here from P to P prime, now we could do a vector. We could draw a vector here to that and do it in component form, but they said write a rule, which is a little bit different. So the first thing you would do is this. You're going to just write down an ordered pair, x, y. That would be all our originals here. Is now going to put an arrow here to the rule that we're going to put. We're going to now do something to x, we're going to do something to y. So what are we going to do to x here on this one to get from P to P prime? We're going to move it to the right 1, 2, 3, 4 units. Each of these boxes is worth 1. So we're going to add 4 to our x. That's what we're going to do to the x. We're going to say x plus 4. We're going to add 4 to it to get over here. And then what do we do to the y to get up to P prime at that point? Well, we're going to be going up, so we're going to add something to the y. We're going to add 1, 2, 3. So we're going to add 3 to the y, and that's the rule. Y plus 3 then. So x plus 4, comma y plus 3, that's the rule they want us to put down here for changing from this original, the pre-image, to the image, the new figure. So number 9, same thing. We're going to go from this one down here to this one. Now you can choose to do P again, or you can choose to do S. It doesn't matter which one you choose. It just has S to S prime or R to R prime. They will all be the same. So if we just try from S to S prime, let's first put down, we're talking about an ordered pair, is now going to be this. All our original X and Y's are now going to be changed here. We're going to be going for the X. We're going to move it to the right 1 unit. So on this one, it's just going to go 1 unit to the right, and I believe it is 1, 2, 3, 4. Yeah, these are all going by ones. So 1 unit, so we're going to add 1 to the x. So x plus 1 there. But then we're going to go down 1, 2, 3 units, so we're going to subtract 3 from the y. So y minus 3 then on that one. So that one's x plus 1, y minus 3. So it should be very simple to just write these rules. Just what are you doing to the x and to the y for each one of these to get from the pre-image to the image. All right, so on 10 and 11 here it says use the translation. So it gives us the rule, tells us what to do to the x and to the y. We're going to add 6 to the x. We're going to subtract 3 from the y. It says number 10, what is the image of point J if point J is at 4, 5? And so first of all, we're going to have to see, okay, what are we going to do to 4? We're going to add, you're going to insert 4 right here, and you're going to say 4 plus 6. So that's going to be 10. So you're going to be doing 4 plus 6 for the x, and then you're going to insert the 5 here for y, so 5 minus 3 for the y. And for this one, since it says j, the way you want to write the new point down, so this is it says what is the image? The image would be the new figure. That's going to have to be j prime. J prime with a little mark there is going to be 10 and 5 minus 3 is 2. So the ordered pair would be 10, comma 2. Number 11 says, what is the image of r prime if r prime is 0, negative 5? So we're going to put 0 in for the x right there. And so it's going to be 0 plus 6. And then negative 5 is going to go in for y, negative 5 minus 3. And since we have this as r prime, and we're going to be, what's the image of r prime? So if you already have a prime, then you need to go and you're doing a new image from that. Then what you're going to have is a double prime. So you're going to say r double prime with 2 marks. And then 0 plus 6 would be 6 for x, negative 5, negative 3 would be negative 8 for the y. And that would be what your translation would be. That is what the image is of each of these. Okay, here's our last one. We're almost done here. Number 12, in a video game, you move a ship 1 unit left and 4 units up. Then you move the spaceship 2 units left, rewrite the composition as a single transformation. So what we have is a composition, that would be the composition of transformations. So it wants us to put it as 1, because we have 2 transformations. We're doing this, then we're going to do this. So as far as for the first thing we do, we're going to move it 1 unit left. So this is our spaceship here. You move it 1 unit left here, and then you're going to move it 4 units up. 1, 2, 3, 4. And so now you're kind of up here in this area. And so it's going to be right up here. So now our spaceship is moved up to here. And then the second thing you do is you move then the spaceship 2 units to the left. So now you're just going to scoot it over left 2 more units. And now your spaceship is over here. So what you can do is you just need to see, okay, if I think here's the tip of the spaceship right there, I can maybe put a point there. And then the new one here, or my one after the 2 moves there, is the tip of it going to be right here. Put a dot here as well. So now I can just go from there to there. So from this dot to this dot, that will be, I'm going to rewrite this as a composition of a single transformation. So we'll start with that x and y. What are we doing to this x and y on this white point to get to this kind of orange point that's right here? So what are we doing to the x? Well, we're going to move the x 1, 2, 3 to the left. So we're going to subtract 3 from the x. So it's going to be x minus 3. And then what are we doing to the y? Well, we're going to move it up 1, 2, 3, 4 units. So we're going to add 4 to the y. So it's y plus 4. And that would be then our rule for this new composition as a single transformation. All right, so that concludes our lesson here in 4.1. Stay tuned for the next segment of transformations in 4.2. I'll see you then.